WebRTC mode enables Orchid Recorder to provide good quality, live and recorded video without requiring a plugin. If you do run into video problems, WebRTC mode provides a variety of statistics for troubleshooting. The standard stream statistics appear at the top of the list. Most of these stats are self-explanatory, but we'll hit the highlights. Keep in mind that the available statistics will vary based on the web browser you're using. In this video, we're using Google Chrome. The camera driver, make, and model are all data points provided by the camera. The uptime stat represents the amount of time that the player has been on the stage in the current session. The connection state indicates if there is a working connection between the client and the server. When it's connected, you should be receiving video. The bytes received represents the amount of data that has been received from the camera via the server. The frame rate displays the number of frames per second transmitted within the video stream. The frames decoded stat indicates the number of frames the client has decoded in the player's current session on the stage. The ICE connection stat provides the status of the ICE connection. ICE stands for Interactive Connectivity Establishment, which is a method used to identify the most direct communication means available. When this stat reads connected, ICE has found a viable candidate pair for transporting video. If the ICE connection stat is failed, no viable candidate pairs were found. Packets received and packets lost provide information about the video transport from the server to the client. If packets lost continues to increase, video quality will decrease and may make it impossible to display video. The NAT count is only available beginning in version 23.3 and will only appear when WebRTC retransmission is enabled. NAC stands for Negative Acknowledgement. This value indicates how many frames of video the browser expected but did not receive. This also indicates how many frames will need to be retransmitted. The connection stat provides information on the selected candidate pair, which includes a local candidate and remote candidate. The local candidate represents the client side, and the remote candidate represents the server side. Subsections of the standard stream statistics display the WebRTC stats that provide details on the local and remote candidates, plus some advanced information. You can expand any of these entries to view more details. The local candidates and remote candidates sections may show multiple unused candidate entries, in addition to the selected local and remote candidates. But why would we see multiple entries from each side, you might ask? Because there are multiple candidate types, all of which may be available for both the local candidate and the remote candidate. Local candidate types, also known as host candidates, are those addresses, an IP address and a port, that are found locally on the device itself. This includes the device's internal IP address, its internal VPN address, and an address for each network card, if the device has more than one. Stun candidate types, also known as server reflexive candidates, are those addresses that are detected by a remote stun server. If the stun server resides on the public internet, like stun.ipconfigure.com, it will identify all of the public addresses that are available on the network the device is on. PR Flex candidate types, also known as peer reflexive candidates, won't be seen very often. These represent the address as viewed from the connection device. This would occur if the device, the server or the client, received a connection request from the other device and the address information was slightly different than the local candidate. Let's return to the chosen candidate pair. This is the candidate pair that the stun server has determined is the most suitable. The system will provide the IP address, the port, and the candidate type for both the local and remote candidate. It also provides the transport type, which specifies the Internet protocol that will be used for video transport. This will usually be UDP, which is ideal for voice and video communication. Let's take a look at a few different candidate pair examples. In this first example, both the local and remote candidates are the local type. In this case, the client and the Orchid recorder server are on the same network. In the next example, both the local and remote candidates are shown using the same IP address, but different ports. This indicates that the client and the server are actually the same device, meaning we're monitoring our video on the Orchid recorder server itself. In our third example, both local and remote candidates are the stun type. It appears that both devices are behind firewalls, so a stun server is being used to acquire candidates using public IP addresses for both. Our last example depicts a situation in which the system cannot find any viable candidate pairs. When this happens, the summary statistics will show that the ICE connection has failed. On the stage, the player will display an error message indicating that the system was unable to open a connection for the camera stream.